Ladies first.
Okay,
Homework.
so first we gotta make the Lewis structure of N2H4. And to start with this, I think the best way to do it is to evaluate the number of valence electrons. So each nitrogen has 5, and each hydrogen has 4, so we end up with 14 total. And then the only good way I've found to do the next part is just trial and error,
Yeah.
and just putting together the atoms.
Forgot I was filming.
I'll take it. Just put the atoms together in different ways and eventually you'll come up with it. But I think for N2H4, you're gonna come up with something along these lines.
Yes.
And yeah, just make sure that you count 2, 4, 6, 8, 10, 12, 14 valence electrons in total. Now, next step, we need to know the bond length for the bond between these two, as opposed to the bond length between N2, which is a triple bond, like this. The bond length is much smaller in N2 because it's a triple, not a single bond. N2 is, as I showed, 2 nitrogens with a triple bond between them and an unbonded parent each. And it makes the bond length shorter as the electrons pull the nuclei together, and Coulomb's law dictates that the attraction increases as distance decreases.
Okay. So the next question was, how does the end-to-end bond strength in N2 compare to the end-to-end bond strength in N2H4? So the bond strength in the end-to-end bond of the N2 is much greater than that in the N2H4 molecule because for this one there's a triple bond, which has a bond order of 3, which is extremely harder, like much harder to break than the bond here, which is just a single bond that just requires more energy to break this than that. So then for the next question, which is identify the hybridization of the nitrogen ions in the N2H4 molecule, you can see that there is, for one of them, there's a lone pair electron group here, another electron group here, another electron group here, and another electron group here. So 3 single bond electron groups and then 1 lone pair, which is a total of 4. So that makes the hybridization sp3.
All right.
Is that it?
Yeah.